Good morning to everyone. In the previous class, we were discussing about some of the problems. In that problems, we have discussed uh, two problems which are of totally different than one another. So, of course, it is also slightly different than the previous problem. So, in this, we can see that a sewer of 300 mm dia, which is flowing full. Very important. So, he has given the diameter. So that is in 300 mm. So then you have to convert this into meters. So then second thing is that it is flowing full. So when you say it is flowing full, so then I can calculate R. That is means say that it is flowing full. So R is equal to A by P. Then pi d square by 4 divided by pi d per meter. So then you'll get that is d by 4. So then he has given the slope, that is s. So that is 1 in 300. So then what will be the velocity of flow and discharge when running half full? Very important. See, maybe it is slight confusing with the last problems. He is saying that it is flowing full, means 300 mm dia it is flowing full. But he is asking that what will be the velocity of flow and the discharge when it is flowing half full, means when it is flowing 50%. Flowing 50%. Then he is asking that is the velocity self-cleansing? That is one more. You have to, after that, when the velocity has been calculated, we have to say that whether it is a self-cleansing or not. So we have discussed two velocities, that is self-cleansing velocity and the non-scouring velocity. One is self-cleansing and one more is non-scouring. So that we already defined it, what is the self-cleansing velocity and non-scouring velocity. So then assume the Mannings is 0.013. Suppose if he has not given, you can take either it is 0.012 or 0.013. This we already discussed how we have to assume it. And the table also I have given, that is Manning's rheosity coefficient, that depends on the type of the pipe. So finally you have to say that whether it is self-cleansing or not. In the previous problems you have not decided, or he has not asked that what will be the, whether it is a self-cleansing or not. You can see that in this previous problem he has not asked anything about that. So then we'll start with the solution of this problem. So first one, what he has given is that apply the Manning's formula, that is V is equal to 1 by N, or we can say it is a capital N, whichever it is, R to the power 2 by 3, then S to the power half. So when he says what will the velocity of flow and discharge when it is running half full? So many students will confuse with this what we can call this one and this one. They will directly take it as 5d square by 4 and they will not consider this half full. So when it is a half full, what you have to do is that, of course, it won't make that much difference, but still it is because r whatever it is there, r is equal to a by p, whether it is flowing half full or what will happen is that 5d square by 4 divided by 2, then 5d divided by 2. Then what will happen is that this will get it will same as d by 4 only. But still, many people will what they will do is that this they will divide it, this won't divide it. That should not happen. So then, if that is the case, what you can do is 0.1 by 0.013. Then r is d by 4. So that is that we already converted into meters. That is 0.3 divided by 4, 2 by 3. Then s to the power half. Slope is they have given slope, you can take it as the problem he has given, that is 1 in 300. So that is 1 by 300. Slope he has given, whatever it is there, that is divided by half. So then when you calculate that, so you will get V is equal to 0.789 meter per second. And if you simplify it, then apply continuity equation to calculate the discharge. That is, discharge Q is equal to A into V. Here it will be a trouble. When you are calculating A, it is not very important. Many people will go wrong. 5d square by 4 and divided by 2. That we have to make it, because it is flowing half full. Here it does not make any difference. But here it will be like 5d square by 8. Then velocity has given, that is 0.789 meter per second. So then if you say it will be 5d square by 8 into 0.789. So then 5 into d is, that is 0.3 square divided by 8, and that is 0.789. So then you will get it, that is 0.02785 meter cube per second. So then, so this is the velocity you are getting, that is Q, and this is the V. Now, you have to decide whether whatever the velocity you are getting, whether it is self-cleansing or not. Whether it is self-cleansing or not. So then we have some standards. 0.45 is meter per second. If it is there, then it may not be any problem, means okay, it is going to self-cleansing. And if it is exceeding 0.9 meter per second, it will scour. Means the limit is 0.45 to 0.45 to 0.9. So it is in the range, whatever the velocity we are getting, it will be in that range. Means it is self-cleansing. So if the value is in between 0.45 to 0.9, we can say it is self-cleansing. Suppose if it is crossing 0.9, if it is greater than 0.9, normally will not consider it as self-cleansing. It will go with the non-scouring velocity. Scouring velocity, it is not non-scouring, it is scouring velocity. So means both are in that one only, self-cleansing as well as non-scouring. Means If this range is there, either your silt or the sand is going to settle at the bottom, or whatever the silt and sand will be there to high velocity, either it will scour. So optimum will be your 0.45 to 0.9. So this is standard. If the velocity is in between these two, it is self-cleansing as well as non-scouring. Greater than 0.9, it is a scouring velocity. It is not the non-scouring velocity. So this is how we have to make some of the decisions based on the value which you have arrived with this problems. Maybe the next class will solve some of the problems related to the uh, that is partially full. So when we are solving some of the problems related to the partial flow, so we have to glance some of the empirical formulas. This we already discussed. Maybe we'll solve one or two problems using these empirical formulas when uh, it is flowing partially full. So we'll continue in the next class. Thank you.